Hey guys, and welcome to Functional Print Friday. So we've got another problem to solve. What's on the bench today is a DRO, and I had planned on mounting this on the lathe, and I thought that 3D printing might creep into this project because it certainly did when I put a DRO on the milling machine, but I didn't expect to be remaking entire parts. So I'd purchased two of these scales for the lathe. This is the one that goes on the cross slide. It does not need to move that far because the cross slide doesn't go that far. And then there's a really big long one here. Let me grab it. Yeah, here's the one for the back of the lathe. This is the one that will be for the carriage of the lathe that has to go like the full length. And I can't even fit this whole thing in frame. But this one is huge and this one looks fine. Unfortunately, the same cannot be said for this little guy right here, and that's really a shame because this one was super hard to get. That big one I just showed you came right from Amazon. There's plenty of distributors of the larger size glass scales and of the size one up from this that I put on the milling machine, if you guys remember when we did that project. Unfortunately, this is like a super tiny one. It's 16 millimeters by 16 millimeters, and I do want this size for the cross slide on the lathe so that it's not in the way. But the only two places I could find that stocked this particular size is an eBay seller that ships out of China and a DRO supply place that also ships directly from China. So I had to choose between the eBay seller or just random website, and I figured I'd have more protection buying through eBay. And I think they are going to take care of me, but so what's the problem with this? Well, there's three different parts here. This is essentially just a dust cover. This piece is fine. This is a mounting rail. This is the part that you actually mount to the machine. And then this is the glass scale itself. It's essentially a linear encoder. And the scale mounts to this mounting rail. And these two holes on the mounting rail are 265 millimeters apart, which is what they should be. Checking the spec sheet for this. Unfortunately, I think what they did is when they assembled this, they cut this housing too long because the holes on the ends are 266 millimeters apart. And I did consider trying to mill half a millimeter off of each end, but then the screw head would only touch partially, and the whole thing is supposed to be a pretty rigid setup. So I reached out to them and they gave me the runaround at first, but after reaching out to eBay and threatening to actually file a complaint against them, now they're offering me some money back to keep it if I can just figure out how to mount it on my own, even though it's the wrong size. So that kind of works out in a way because I was going to modify this mounting rail anyway. Now, I can't really modify this one anymore because these holes are the wrong distance apart, and the distance that it's off by is too close to try and modify these. These holes are threaded. I don't know if you can see that there in the video. So there's no way that I'm going to get these holes 1 millimeter closer together and get it rethreaded. It's just, there's not enough room to work there. It's not possible. And yeah, I did try and mount it up anyway. That's how I realized it was the wrong length because it just doesn't go. There's no way. In fact, I actually started to strip out one of these sides, trying to thread it in any way before I realized it was the wrong length. So let me take you over to the lathe and I'll show you what I mean. Okay, so we're over here at the lathe and this is the cross slide. This is the piece that crosses back and forth across the ways of the lathe and essentially controls the diameter of the material that you're cutting, or what you're cutting the workpiece down to from a diameter perspective. So it moves back and forth this way. And this is that mounting rail, and it would go sort of here-ish, not exactly there, but in that vicinity. And there's a problem with that because on this lathe, and in fact many lathes, the set screw that locks the cross slide is right there. So here, I'll take it out for you guys. It's just a grub screw that tightens down on, I believe, the gib for the cross slide. And in fact, if you buy this lathe from Precision Matthews, the company that I bought it from, with a DRO pre-installed, they just cover that and you have no access to it. So what I did instead was I made a custom bolt to replace that grub screw that goes in the same place, and I made the head on it really, really, really thin, and I made the length of the bolt just perfect so that before I get the bolt all the way down to the bottom, it bottoms out and presses against the gib right before the head of the bolt bottoms out against the face of our cross slide. And my thinking process there is if I take a really thin wrench, I'll still be able to lock the cross slide as long as I leave myself clearance here. And that's what my blue tape is marking. Like I kind of figure that's about the swing that I need with the wrench to be able to get it off of there, flip it around, get it back on, and tighten and loosen this piece. And this is also, when loosened, where it's not making any contact at all, it's not putting any pressure on the cross slide, I only need about 150 thou from this face to the head of this bolt clearance back here. So I thought, well, I can either space this away from the cross slide, that 150 thou, or maybe I'd mill some material out of the back of this in sort of that shape so that I could reach in there and still get that wrench on that locking bolt head. But if we have to remake this piece and we can potentially 3D print it, we could actually design that right into it. Let's go back over to the bench. Okay, I've actually got the scale connected to my touchdro box here, and I've got the touchdro software running on this phone just to see this working. And I mentioned that this is a 1 micron scale. That's actually what made this so hard to find. I found plenty of sellers like on AliExpress and other places that have the same dimension scale, but in 5 micron. I wanted 1 micron because being on the cross slide of the lathe, it's essentially measuring the radius of the material, but we're actually cutting a diameter. So we need a scale that is twice as accurate as the accuracy that we want for the diameter. Hopefully you can imagine that. So if this is the stock that I'm turning, so imagine this is the piece that's turning and this is the tool. I'm cutting on this face out here, but this piece is turning, it's going around. So I'm making that cut all the way around on the diameter. So however much I take off, if I take off 1 millimeter of material, I've actually reduced the diameter of the part by 2 millimeters. So to get 5 micron accuracy, I can't use a 5 micron scale, I would need to use less. Hence the 1 micron scale. This will actually give me 2 micron resolution on the diameter of the part. And this is pretty cool if you've never seen one of these linear encoders work. As this guy slides back and forth, you can see this here. If you're not at all familiar with these, check out, I'll link it down in the description below. I 3D printed parts to mount glass scales from the same company, SINO, on all the different axes of my milling machine. So I initially thought there's no way that this is going to work 3D printed because whatever material we 3D print this out of, it's not going to be anywhere near as rigid as this aluminum. But the thing is, I don't think it has to be. And there's some tricks that we can use here in the way that this is assembled that's going to give us some more rigidity. Now, if you look across the top of this extrusion, and hopefully it'll focus on this, you can see that there's a recess here in the top of this. And that's for this cover to key into. It keys in and there's 2 screws on either end that hold it in place. So this dust cover is essentially providing rigidity, keeping me from bending it in this direction. So keeping me from, say, bending this into a V once this cover's in place. So we'll get rigidity as long as we use this aluminum dust cover on our 3D printed part. And we don't really need rigidity in like this direction. If it bends a little bit this way, it's not the end of the world because this is almost kind of acting like a, well, it's not quite a shim because these mounting holes here are how this is designed to actually mount to the machine. And then the mounting holes on the scale itself go into these threaded holes here. So we really only need rigidity between where our mounting holes that go onto the casting of the machine are and where the scale mounts, because the scale itself is quite rigid. So maybe we can move these closer. I don't know, I'm getting ahead of myself. I think the first thing we're going to do is let me try and reproduce this part 3D printed. All right, and here is that design complete. And I'm not going to spend a ton of time talking about it because in reality, it's just an exact copy of that aluminum extrusion with two small changes. First one is, rather than have threaded holes here for that dust cover to fit down in, I just made them through bores and made a slot to insert a nut. And here, if I kill this face, it probably makes it easier to understand what's happening there. The idea is I'm going to press in, I think it's an M2.5 nut. I'll push that in place, and then when we put the cover on top, this should give us plenty of grip. Because again, we want to tighten that dust cover down really tight so that we get the benefit of that extrusion keyed into this to keep this guy from bending in this direction. The other change I made was, kind of the rather obvious one, since the mounting holes on that scale are not at the correct distance apart. Our mounting holes here are 1 millimeter further apart than the aluminum extrusion. And I didn't do anything with these yet. I really just want to make sure that we're at the right size. I did make the through bore on these the tap size, so I guess we could try and force the screws in or tap these, but we're not going to use this part anyway because we still need to figure out that notch on the back here to be able to get at that bolt. So, all right, I'm going to print this out and let's see how we did. All right, and our first test piece is complete, and it honestly looks pretty good. I printed this on the X1C at 0.12 millimeter layer height. It's just plain old PLA, and it does not have a lot of rigidity in this direction. It has a fair amount of rigidity in this direction. I can bend it. I can see it flexing a little bit, but it's really this direction that we need this guy to be rigid in, and we should pick that up from this. So let's try that theory. See if this keys in the same as... Ooh, yeah, that keyed in nice. Yeah, and there's a little bit of play there. I could probably tighten up the width of this recess section because I can feel it rocking around in there a little bit, although it's probably going to tighten up when I put those screws in. Speaking of those screws, we have those slots for the nuts to go in. Let's see if we can get one of those nuts in there. All right, that is super tight. I think I could probably press it in there, but I'd like to open those holes up a little bit bigger. And the other problem that we still have is these holes here. I didn't do anything other than just make these roughly the tap size in the design, because we're not actually gonna, we're not gonna use this piece, but would like to see if it actually lines up at least. You guys can't see through these lined up with my eyeball the way I can, but maybe you can see that in the video. Looks like we're lined up on both sides. I'm not even going to bother trying to put the screw in because there's nothing for it to thread into. But I think we have enough material here that we could press in a hex nut from the back. Yeah, I don't see why we wouldn't be able to do that. And I also think we'll be able to increase this a little bit. I put this together with one end screwed in off camera while I was waiting for this to print, and I measured it with a feeler gauge, and there's actually this whole thing stacked up. So remember, there's a dust cover here too, so this goes on here, the dust cover keys on. If I can hold this upside down, and there's actually almost a full 1 millimeter gap between the scale and the dust cover. So what I think I'm going to do is bring this face out by, say, 0.7 millimeters. I think we can drop the bottom down a little bit as well. We don't want to get into the area where the reed head is, because we have to still mount this to the lathe as well, and that's probably going to be another 3D printed part because we have to go sort of out from the face of the casting of the bottom part of the carriage and up to hit these mounting points. But if I put this guy on, yeah, that's lined up. I'm thinking we can come down a little bit, probably another millimeter down here, which should give us, any material we add to this is going to give us additional rigidity. And I'm not a huge fan. It printed really well, but that lip down here on the bottom is only 1 millimeter. If I can, yeah. I can separate that with my finger. I mean, we're not going to have that much force on it mounting in the machine. I think that lip, I think the only purpose it serves is actually just to give you a surface to put this up on and sit it against when you put those 2 machine screws in. I don't see what other purpose that lip serves, but we'll extend that down by another millimeter just to give this whole thing some more strength. The other thing I'm thinking about is, I talked about the only real rigidity that's going to matter is the rigidity that we have between these hard mounting points that are going to mount to the casting. Let's go back over to the lathe, actually. It's going to be easier to explain there. Okay, so this guy's going to be mounted up here. Let's try that again. Okay, so this guy's going to be mounted up here like this, except we still haven't actually modified this design yet to accommodate to get a wrench down in there for that bolt. I just took the bolt out so we can put it up against it. The only place we really need this to be rigid is between this mounting point here and where the actual scale screws into this. The rest of this doesn't really matter. If it flexes here in the middle, it doesn't matter. We really only need it, again, to be rigid between this point here and this point here. So what if we just move these over closer? I don't see any reason why we can't make the mounting points closer to the ends. I guess the only downside to that would be we're no longer following the standard of these scales, but that shouldn't really matter. I'd probably want to come over far enough that if we ever do actually have to use, if this doesn't work out and we have to use the aluminum one, I can machine additional mounting points in an aluminum part. I just have to make sure I come over far enough that we completely clear this one. So maybe we move these, I don't know, maybe 15 or 20 millimeters closer to the end. So, all right, in summary, I think we need to bring this face out a millimeter, bring this face out 0.7 millimeters, bring the bottom face out 1 millimeter, move the mounting points closer to the ends, increase the size of these slots for the nuts to press into. I'll also check the clearance of these holes because the fasteners should clear these holes and drop into those nuts. Same thing for these. I'll have to increase the size of these so that the fastener actually clears that, and then put a hex in the back so we can press a hex nut in. And yeah, I think that's going to work. So let me go make those design changes and I'll bring you guys back. All right, and here is our updated design, and I'm pretty pleased with how this looks. I think the notch on the back looks pretty good. I did add recesses on the back here to press hex nuts in so that when we mount through with those socket cap machine screws through the scale, this will pull up against those hex bolts rather than just trying to thread those holes. I did increase the clearance a little bit on these guys since I couldn't quite press those nuts in. I mean, I'm sure we could have done it in the arbor press, but those should be, it should be a slip fit. Like, they shouldn't fall out, but we really shouldn't have to press them in place either. I moved our mounting holes way out to the ends as far as I was comfortable doing. I didn't want to start to get into any of the geometry for our other features here. And I did thicken this guy up. You can actually see now that the top of this rail is thicker on this side. And I did check the aluminum extrusion for the dust cover. There's nothing that would prevent this from keying in, even if this, this top part here is wider. So I brought this out 0.7 millimeters, and then I dropped the bottom down by 1 millimeter, just to give this guy a little bit more sort of beefiness to it so that we pick up some extra rigidity since that material is not going to be in our way. So, all right, I'm going to print this out and fingers crossed that everything fits. All right, and our revised part is completed and came out really nice, just like the first one. And you can see how much I moved those mounting holes over towards the end. Because again, we really only need this piece to be rigid. The center distance of this mounting point here and the hole over here, and same thing on this end. And by the way, the reason that these are in different directions is so that if the holes that you drill on the casting are slightly off, you have the ability to move this thing in this direction and in this direction a little bit until you get exactly where you want to be. And I've got our notch back here for the wrench. So I think it's time to actually try putting this one together with all the fasteners and see if it works. Okay, I think we need slightly longer M3 machine screws here than the ones that it came with, which is okay because I should have those. Okay, these may actually be too long, but that's okay. They can be cut down. It's not going to matter for the purpose of just testing this right now. Yeah, those are just a little bit too long, but that's okay. I can trim these down on the lathe if everything else works. Let's try our dust cover. All right, that all went together really nicely. The dust cover tightened down really nice on that notch on the top, and the whole thing is now really nice and rigid. And these tighten down nicely as well. Like I said, these are a little bit long, but we can just either get the correct length machine screws, or I can shorten these on the lathe. So now I'm kind of at a crossroads. I'm not sure what to do. I mean, I can certainly return the scale and get my money back, and we can use this, everything we learned from this, including the size of this notch for the wrench, to machine the replacement part when it comes. Or we could just roll with a 3D printed one. I think this is going to work, particularly if they're willing to offer me some of my money back on this one, given it's not exactly the right length to use on the rail. Kind of tempted to go with this. Oh, you know what we didn't do? We didn't actually check to make sure this notch gives us enough room for that wrench. Let me pull the dust cover off. We'll check that. The other thing to think about here is whether we use this 3D printed one or we use the aluminum one. The dust cover itself is still blocking access to that bolt. So we could either notch the dust cover, I could do that on the milling machine, just that little notch out of it, or we can leave it solid and just remove it whenever we need to actually lock the cross slide, because, probably not going to lock that cross slide. I'd be surprised if I locked that cross slide more than 2 or 3 times a year. So it would be nice to keep chips out of there. I guess if I notch it, we could 3D print like sort of a filler piece at the top that keys in. I'm getting ahead of myself again. Let's go see if this clears. I know what, we actually got to put that bolt back in. Yeah, that's plenty big enough. In fact, I could even make it a little bit smaller, but I think I'm going to stick with that size. It gives me more than enough swing. I don't even need to flip the wrench around to use the other angle. If I want to tighten that up, yeah, there's plenty of room there. Give you guys a better idea of what that gap actually looks like from above. And you can see the daylight behind that bolt. And I think we are actually, yeah, that's the locked position. Let me unlock it, and I'll show you how much clearance there is. So that's unlocked right there. You can see I'm able to turn that with my fingers, so we don't have any tension on it at all. And there's still just a tiny bit of daylight behind it. Now our tape is holding us against, away a little bit, but the tape is not as thick as the gap that we still have there. So that's good. Okay, so it's time for you guys to weigh in on this. What do you think I should do? Because the next step is to actually drill into the casting of the cross slide to mount this. I really don't want to do that and then make a set of holes that I end up not being able to use. I mean, I guess even if we end up using the aluminum extrusion, I can mill a second set of mounting holes in the aluminum extrusion so that we still use the same holes that I'm going to drill into this. But either way, nothing I've done up to this point is destructive, and the very next step, we're going to start drilling into the actual cross slide. So let me know down in the comments what you guys think. Am I missing anything here? Is there something I'm not thinking of? Do you think this part is going to hold up in PLA? I'm leaning towards yes, particularly since we got the distance between where the scale mounts to this and those mounting holes so close together. We're not asking a lot of that PLA. We're only asking it to be rigid in that thin section, and we'll still have the added rigidity of the dust cover keyed into that. But let me know what you guys think. What would you do? All right, guys, as always, thanks for hanging out in the shop with me for this week's sort of thought process and 3D print. And if you have any opinions on this, if you have any thoughts, particularly if you think there's something that I'm just not thinking of, please put it down in the comments below. If you enjoyed this video, if this is the type of thing you like seeing on YouTube, take a second, hit that like button. It really helps out the channel. And if this is your first time here, we do a new functional print every single week, every Friday. So if you're into that, check out some of my other videos. And if you like them, hit that subscribe button. And guys, if you do, I'll see you next Friday.